In this video, we're going to look at simplifying an expression using the rules of exponents, and this will include negative exponents. Here are all the rules of exponents that we'll be using. We reviewed all of these in a separate video, and I'll be referring to these as we go through our example. In this example, we're going to simplify the expression using the rules of exponents, and we want only positive exponents in our answer. First, I want to remind you that there may be more than one rule that you could apply to an expression at a given time. For example, in this expression, since inside the parentheses I have x's in the top and the bottom, and y's, I could simplify those first before I do anything with this outside exponent. I'm actually going to start with the outside exponent, but we should get the same answer either way, and I do encourage you to experiment with different methods to see if you get the same answer. Starting with this outside exponent, notice that we have a quotient all raised to a power. And we have a rule for that. It's called the power of a quotient rule, where the exponent is applied to both the top and the bottom separately. So here we have the numerator raised to the negative 2 power, and the denominator raised to the negative 2 power. Now we need to use another rule. Notice that we have a product of 4 factors here raised to a power, and in the bottom we have a product of 2 factors raised to a power. The rule for that is the power of a product rule, where the exponent is applied to all of the factors within the product separately. So here is all of the factors from the numerator, each raised to the negative 2 power, and both of the factors from the denominator, each raised to the negative 2 power. Now let's make some room here before we simplify further. So here's where we left off. The next rule I want to use is going to allow me to simplify these factors that have a power all raised to another power, these ones that have the parentheses. And that's called the power of a power rule, where we multiply the 2 exponents. So I'm going to do that here with the x. I'm going to multiply the 3 and the negative 2, on the z, the negative 5 and the negative 2, and also for the ones in the denominator as well. So the x now becomes x to the negative 6. Z, I multiply the negative 5 and negative 2 to get positive 10. The x in the denominator, I get positive 8 when I multiply, and the y gets negative 4. Now we're at a point where we have a choice again. I could simplify using quotient rules because of these variables here in the top and the bottom, or I could get rid of the negative exponents first and then simplify. I'm going to take care of the negative exponents first. Let me make some room again. Here's where we left off. The rule for negative exponents says that if we have a factor in the top with a negative exponent, we can move it to the bottom, change it to a positive. And if we have a factor in the denominator, we can move it to the top and change the exponent to a positive. So let me identify all my negative exponents first. Here's 3 in the top. Those are all going to move down to the denominator. And 1 in the bottom is going to move to the numerator. Here they are. I've changed all the exponents to positives after I moved them. And now the last thing I have to do is take care of the y's, because I have 1 in the top, 1 in the bottom, and the x's, because I have 2 in the bottom. And we have a quotient rule that says we subtract the exponents, and a product rule which says that we add the exponents. I also like to just think of this as canceling common factors when I have one's top and bottom. So the y's, when I cancel 2 of them, I'm going to be left with 2 in the numerator. And the x's, you can see that when we multiply these all together, we're going to have 6 plus 8, or 14. So here's the subtraction, which is going to leave me with y squared in the top, and the addition, which is going to leave me with x to the 14th in the denominator. And I also simplified my 7 squared to be 49. And that would be our final answer. This is the simplified form. Here's all the steps that we have just applied, somewhat abbreviated, but I highly recommend that you show steps just like this when you're simplifying these expressions, and it's not a bad idea to even indicate the rules that you use at each one of the steps. Now I want to end by answering a question that I often get. How do we know when we're done simplifying? There should be no parentheses in your answer. There should be no negative exponents. Each variable should only appear one time. That's actually assuming that there's no addition or subtraction in the problem. But the majority of these, if not all of them, will just have products and quotients. And this last one actually is more general. This kind of takes care of all of them. No more rules of exponents can be applied. So here was our answer. Notice we have no parentheses, no negative exponents. Each variable appears one time, x, y, z. And if you look over all the rules of exponents, there's no more that we can use on this. This is as far as we can go.